Okay, so this is computer vision and freeform construction. The cluster wanted to explore the possibilities of computer vision in the realm of craftsman construction, especially in the tile bolt type of structures. This type of bolts, in essence, require no fails work because every tile stands next to the previous one, so you don't need any support, or at least no a permanent support structure underneath, but you have to provide a guidance. And we wanted, the system that we proposed to the cluster was one that could be used in developing countries, but just using off-the-shelf cheap materials, and always trying to avoid complex arrangements underneath it, like the one you see in this beautiful picture by the Philip Bloch group from the ETH. So we came up with a system that combines very cheap components, basically a webcam. It doesn't have to be the best webcam in the world, although we brought two of the best, and now they are destroyed, but that's another story. And just computers and paper markers. And it's good because you can also use free and open source libraries like OpenCV and Aruco, which are the ones that we're using. So we proposed the cluster a series of challenges. The first two were just to construct two bolts using the workflow, and also try to improve the workflow in the sense of tiling, on informing the design, and also on leveraging sensors like Kinect, and in order to make it easier to use. This is the proposed cluster arrangement at the Bartlett. These are not the shapes that were built, just some proposals. So we started with the first topic, which was construction. First day, the participants just got involved and split in two groups to design and decide which wall was going to be built. And it was great to have Semek with us because he almost ran half of the group, and it was interesting because this is such a talented group of people, and that they got to work together so well that by the end of first day we had two beautiful shapes to get built, right? The tools that were used were quite diverse. We used from Rhino, GC, Kangaroo in both systems. We used processing. Also a lot of manual work, which is something that, as Tristan said, is allow them to explore the difficulties of the shape. Julián and Jose Maria help us informing the students about the concerns, about the problems that these shapes were going to have. Some of these concerns were taken into account when developing more parametric tools afterwards. It was also great to have Daniel and Robert on the neighbor cluster, because we were using Kangaroo a lot in our workflow to design the shapes. Here you can see both balls being basically created using these tools. Right. Then the system itself, this is Lauren showing us how it works. You basically take a webcam, which is connected to our computer, and you point at a marker that has to be in a stable location in your site, which was quite hard to accomplish in the Bartlett, because everything was moving so much. And then you point at you just point the camera against the marker, and it gives you the distance to the ideal surface on screen. So that's the kind of feedback you get from it. Right. So using that system, we proposed the participants to construct two bolts. In the first one, we had the luck to count with Carlos Martin, which is a craftsman we brought in from Spain. It was quite interesting because Carlos doesn't speak any English, but we were able to let the students be with him and learn from him, and he was involved in the ceramic tile bowl that maybe you have had the chance to see at the exhibition. Meanwhile, we were having the other bowl constructed exclusively by the participants. This way, we had the chance to compare which which amount of craftsmanship, I would say, I don't know how to say this, how much is the system helping us and how much is the ability of the bricklayer. In this bowl, we were using a different material. We were using foam glass, which is a cellular glass, which could be cut just using a knife. And so it was a much more flexible material, although it was quite messy. And I have to say sorry to our neighbor clusters because of that. Right? And by using those tools and having such a different people in the same site, beautiful things started to happen. This is a time lapse of the ceramic bowl. Then you can see how we made a mistake and we had to start again. And it's basically just helping the bricklayer, informing him how he's doing with the shape. It's not about a huge precision. It's not about providing like millimeter precision. It's just telling him if he has to go up or down, if he's doing right with the shape. Of course, as of today, it's nothing. It's not a system you can use on your own. You need some kind of assistance, but we think it's getting better. And by getting it to smart geometry, we were able to improve it a bit more. Yeah. Meanwhile, on the other side, on the other board, things were going also good. We started with half day of delay, but since we were using the foam glass and we had a lot of people to work in it, we catch up quite easily. Right. So there you can see it's Lauren and Danai and Nan just taking measures. Eventually, we finished the tile bolt and we were able to use the two cameras on the foam glass one. Right. This is Carlos and just taking the last measures. Here we are about to close the bolt, right? This is Elizabeth helping Carlos to close it, right? So you see the marker at the back, and that's the first layer of the tile bolt. That's the one that is ugly because it has to stand, right? And then the other ones come on top and make it beautiful. Okay, so we are about to finish the second bolt, right? And this is finished. And this is Elizabeth again helping Carlos place the last brick that close the shapes, right? So it's self-stable, right? This is Fabiano. It was great to have Fabiano also on board because he was so perfectionist. He just took the bolt and make it his, right? And he just brushed it all, just added the last layers of plaster. So if it's beautiful, it's maybe because of Fabiano, right? This is it. Right. But meanwhile, we had a lot of interesting people working besides in the tables. Because we had all the challenges. We were looking for tiling proposals. We were looking for structural analysis, and also for trying to use the Kinect in a way that allow us to get more information and use it in a better way. So some of the participants started working on that. For instance, this is some work from Marta, who started thinking about tessellation, how we could cut the tiles. Since this was the foam glass, this could have been possible, just cutting them. Although we didn't have much time. Of course, time is always an issue in smart geometry, and we just tried to make it simple, right? This is the work from Ricardo, Fabiano, and Silvia, showing basically manual work at the beginning for the tiles, and then some attempts to automate it. This also work from Andrei and Ricardo. Andrei came with a definition that helped the team by laying guiding joint lines over the foam glass bolt. We also had Danai testing the surface. Because since we have to break it by tomorrow, we have to demolish it tomorrow, we thought it would be nice to get some kind of idea of how much weight could it stand. And that's it. We're going to try that tomorrow. Let's see. Okay. And apart from that, we had Semek, Lauren, Connor, and some others, and also Miguel, trying to work with the Kinect, trying to see what precision we could get from it, how we could use it in order to amplify the work of the bricklayer and to complement our core system. And I have to say it worked pretty well. Miguel and Juanma just put together a time-lapse 3D model of the construction. And Seme with Lauren and Connor were able to cast or to project some information about the model on top of the ongoing construction. I don't know if you can see it properly, but there you see on the left of the screen you see the temporary bricks which are standing, the two main arches that we built on that one, and here you see how they were able to overlay the ideal solution against the ongoing one. This was happening live at the cluster, right? All right. So to summarize the results, we would say that CV has proven to be an inexpensive method for shape guidance that simply works. You could get a local positioning system by less than 50 euros, yeah, with a precision of about 10, 20 millimeters. Having two bolts built with different materials by completely unexperienced and fully experienced people allow us to prove that the system works, that just by providing a guidance, we were able to build a freeform, more complex shape, counterintuitive shape. But the truth is that real construction requires adaptability, and the real problems we faced were much beyond the shape. They were about how we were tiling them, the order of construction, because since you need some kind of support between tiles, you might want to plan that in advance. So we got a lot of to-dos for the future. Maybe inform the shape with these construction constraints, improve the ease of use. We see that these sensors, the Kinect and other similar, will be the answer for this. And for sure, we need more time for computational problems. It was great to build these two bolts with all the participants, but at least I feel we didn't have much time to discuss the really computational problems. So, thank you.